Okay, so as it says on the top, but don't look at the paper. It says the power of math and poetry. The school loved that "and" word. I think they were choosing between and but had that like but connotation. So they were like the power of but, no, the power of and. Okay, so this is a poem about the Konigsberg bridge problem. Really famous problem that kind of spawned graph theory back in the day. Not like the 70s, but back in the day. You know? Okay, so let's just start the poem. Chalk. Okay, so this is a. Don't look at the sheet, because then you know what I'm going to say. What bridge am I going to talk about next? Oh, good. Okay, this is a poem about the Water Street Bridge over there. Well, not really. I'm lying a smidge. Brian Bridge and smidge. All right. This poem is really about a subject called graph theory. A subject like an onion. It'll make your eyes teary. So prepare yourself to cry for graph theory joy. Okay. In 1700, in an old Prussian town called Konigsberg, 7 bridges connected 2 islands and 2 banks to each other. Were like this. The townspeople tried to cross 1 bridge at a time and come back to the place where they started and find that no bridge was crossed twice in this walk they took. They couldn't solve this problem, but they knew where to look. So they tried to cross the bridge, 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 cross the bridge. Are you just going to say that?
I can move. Okay.
And then cross the bridge, cross the bridge. Get the people in it too. There are people.
Oh, okay.
I don't want to just be
I got it.
Okay. Okay. So, enter the mother of graph theory. In 1700, she did give birth to all of graph theory, but the labor didn't hurt because the mother was a brother named Leonard Euler, and he cooked up graph theory like chicken in a broiler. These are flames. No chicken is happy in a broiler. Okay, but his name is important. Leonard Euler. Almost as cool as Euclid. Equally cool. Leonard Euler. And don't say Euler. Euler. In fact, let's just spell it as it sounds. Okay. Instead of the Konigsberg pictures of land masses and water, Lenny Euler said, each land mass is just a dot, and if a bridge connects 2 dots, then a line we got. So there you got it in a nutshell. That is graph theory. Dots and lines, so your eyes get bleary. So this whole picture becomes the following. We have 2 bridges connecting A and B. We have 2 bridges connecting A, B, and C. We have 1 bridge connecting B and D. And we have this whole landmass is just a dot. So D is connected to A via that bridge, and D is connected to C to that bridge. And boom! This is the new problem. Now, can we cross every edge of this graph exactly once without repeating an edge? And from wherever we start, that's where we end. Can we create a circuit/cycle of that nature? So you want to walk this graph crossing each edge once. Euler said each time you pass through a dot, you use 2 edges. Brilliance! I rhymed brilliance with once. That was the key to the bridge problem, you see. Get ready. A connected graph has no other circuit if and only if it has all vertices of even degree. It's a parity thing, you see. Even or odd, yo, for a graph, homie G. You're Nick, I know. But you could be homie G. All right. There's a lot more to say about graph theory, but this rap would get old and your ears would get weary. So instead, let's start class. Words. Begin. Stop.